Join me as I challenge myself to navigate the crazy time zones of our solar system. Can I figure out how time works on different planets? You know, when we think of time zones, we usually think of the ones on Earth, like New York time or London time. But did you know that time zones exist in our solar system too? And they're way more mind-bending than anything we have on our home planet. On Earth, time zones are largely defined by our rotation and orbit around the sun. But in the solar system, it's a whole different ballgame. With planets and moons moving at different speeds and having unique gravitational forces, time gets warped and twisted in ways we can hardly imagine. One of the biggest challenges of timekeeping in space is dealing with the discrepancies in time perception. You see, time isn't absolute, it's relative, and it depends on the observer's frame of reference. According to Einstein's theory of relativity, the stronger the gravitational force, the slower time passes. That means if you were standing on a mountain on Earth, you'd experience time slightly faster than someone standing at sea level. But when you scale up to celestial bodies like planets and stars, these effects become much more pronounced. Take Mercury, for example. Being the closest planet to the Sun, it experiences an intense gravitational force. As a result, time on Mercury passes about 38% slower than on Earth. That's a huge difference. Imagine celebrating your birthday on Mercury, only to find out that your friends on Earth have already celebrated it a week ago. Yeah, it's that trippy. Another challenge is dealing with the varying speeds of celestial bodies. When you're moving at high speeds, like in a spacecraft, time appears to pass slower for you relative to a stationary observer. This is known as time dilation. The faster you move, the more time slows down. It's like being in a real-life video game where time is your biggest enemy. Let's dive deeper into some specific examples. Take Mars, for instance. With its 24.6-hour day, it's not too far off from our 24-hour day. But here's the kicker. Mars has a really weak gravitational force, which means time passes faster there than on Earth. Scientists have to account for this difference when they're planning Martian missions. They need to sync their clocks with Earth's time to ensure seamless communication. Jupiter is another story altogether. Its massive size and gravitational force create some crazy time effects. The planet's day is just under 10 hours long, but its rotation is so fast that it creates some wild time distortions. Near the equator, time passes about 10% slower than at the poles due to the planet's rapid rotation. It's like having two different time zones on the same planet. Imagine being a scientist on one of Jupiter's moons, like Io. You're trying to conduct experiments, but you have to account for the moon's own time distortions, as well as Jupiter's gravitational influence. It's like trying to solve a cosmic puzzle where time is the ultimate variable. So how might future space travelers manage time travel and time zones across the solar system? One fascinating possibility is the concept of time hubs, centralized locations where spacecraft can synchronize their clocks with the local time zone. It's like a cosmic Grand Central Station where time is the ultimate currency. As we venture deeper into the solar system, we might also develop new technologies to manipulate time itself. Imagine being able to slow down or speed up time at will, allowing you to explore distant worlds without worrying about the constraints of time. It's a mind-blowing concept and one that raises all sorts of questions about the nature of time and space. As we wrap up this journey through the weird time zones of our solar system, let's recap the key points. Time isn't absolute, it's relative, and it depends on the observer's frame of reference. The solar system is full of unique time zones, each with its own set of challenges and opportunities. And as we explore further, we might just discover new ways to manipulate time itself. So, which planet would you like to visit first? Let me know in the comments below. And don't forget to check out my other videos on space exploration. Thanks for joining me on this cosmic adventure.